this example, we are going to look at a data set where we're going to be given the mean and the standard deviation of that data set, and it's going to be normally distributed, and we are going to find certain probabilities. And the way that we're going to do that is we're going to take the data values and we're going to turn them into z-scores and then use a table to find the area under the curve, where the area corresponds to probabilities that we want to find. So in this example, you decide to buy the 2020 Ford Edge. If the Edge gets an average of 24 miles per gallon and a standard deviation of 2.3 miles per gallon, along with determining the z-score interval, what is the probability your Ford Edge gets? In the first part, we're going to say less than 22 miles per gallon. All right, so I always like to start these problems by making a sketch. So again, assuming that this distribution is normally distributed, if I sketch myself a normal curve, in the data set that I'm given, it has a mean of 24, so I'm going to put that right smack dab in the center of my curve, and it has a standard deviation of 2.3 miles per gallon. We are being tasked to find what is the probability that this Ford Edge gets less than 22 miles per gallon. Well, with relationship to the mean that I marked here in the center of my curve, 22 is less than 24. So when I label 22 along this horizontal axis, I'm going to put it to the left of 24. So, and it doesn't have to be perfect. I'm just going to put a mark to the left of it that I think represents 22. And I want to find out what would be the probability that the Ford Edge gets less than that. So with respect to 22, I want it to be less than. So in order to find that probability, we're actually going to find the area under the curve from 22 and then the values less than it. So for the 22, I'm going to draw a line up until I hit my curve, and then I'm going to shade the area under the curve that would be to the left of 22. That's the area I want to find. That area corresponds to the probability that I ultimately want to report. In order to use a table to find areas, we need to convert everything to z-scores. All right, so to convert this to a standard normal distribution, let's go ahead and get the z-score for this value. So for 22, its z-score would be, again, the data value minus the mean divided by the standard deviation. So in this case, it would be 22, which is my data value, minus 24, which is my mean, divided by my standard deviation, which was 2.3. Right, if you pop that into your calculator, you get negative 86956, and there's some more stuff after that. Okay, so when we work with z-scores, we would typically work with them out to 2 values, because that's what we're gonna need, 2 decimal places in order to find it in my table. So if I take it out to 2 decimal places, this is going to be approximately equal to negative 0.87. That's going to be my z-score. So let's draw ourselves a new curve, because we're now going to be working on the standard normal distribution. The standard normal distribution has a mean of 0 and a standard deviation of 1. And my new value is going to be this z-score that we just found, which is negative 0.87. So negative values with respect to 0 would be to the left of it, which we expected, right? Because it's going to correspond to this curve we had just sketched, right? We're just kind of doing in math we call this a transformation. I'm going to label negative 0.87, and I'm going to shade again the area to the left of it, because I want to know what that the probability of getting that or something less than that. So let's go ahead and find that area. Our table is already set up to give us areas to the left. I want an area to the left, so life good looks good there. So our magic value that we're trying to find is negative 0.87. So here we go. We go to the table. We look for the negative z-scores and negative 0.87. So here's negative 0.8 right here. So in that row, I need to go to the value that I want in my hundredth spot, which would be the 7. So if I find the intersection between the row I want and the column, we get a value of 0.1922. This area right here is 0.1922. Alright, so the z-score interval that I was looking at I want my z-scores to be less than 0.87. Okay, this ultimately gave me an area of 0.1922. So to tie back everything together, this comes back and answers my original question. The probability that the edge gets less than 22 miles per gallon is 0.1922, or if you want to think about that in terms of a percent, that would be 19.22%. Alright, so what we did there is we took our data value, we turned it into a z-score, and then we made sure we were paying attention to, for respect to that z-score, what areas I was trying to find, and then we used our tables to find that area, and then that answered our original question. So for the next part of this problem, we want to find the probability the foredge gets more than 27 miles per gallon. So again, and when you get comfortable with this, you don't necessarily need to sketch the curve for the original data set, but I like to, just because I like to see what's going on. So remember, my original data set has a mean of 24 and a standard deviation of 2.3, and they're asking me about the chances I get more than 27 miles per gallon. With respect to my mean of 24, 27 would be to the right of it. Right? So I'm going to put a marker roughly where I think 27 would be. Doesn't have to be perfect. This is just kind of a sketch so I can wrap my head around what's going on. And with respect to the 27, I want the values that are more than it. So the values that will be to the right of it. So I'm going to put a line up from 27 until I hit my normal curve, and I'm going to shade the area to the right of it. That is the area that I'm trying to find. That area will correspond to the probability I want. In order to find that area, we need to figure out for this value what is its z-score. So this value's z-score is going to be the data value, which is 27, minus, I'm going to do this in a different color. The z-score is going to be 27 minus 24, my mean, divided by 2.3, which is my standard deviation. Popping that into my calculator, I get 1.3043 ... Taking that out to 2 decimal places, I get 1.30. Alright, so let's translate my information to a standard normal distribution. So just draw a new curve. The mean is 0, the standard deviation is 1, and the z-score I want to mark is 1.30, so that would be somewhere over here to the right of 0. And then we're looking to have it be more than that value, so I want to shade the area to the right of that. So ultimately the range I'm looking for is I'm trying to find the area where the z-scores are going to be greater than 1.30, and I want to find that corresponding area. Now from my sketch I can see that I have shaded area to the right. Remember that when we look things up in the table, it's going to give us area to the left. So I'm going to look up 1.30 in my table. All right, so 1.3 would be right here. 0 would be right here in my first column. So if I find their intersection, I get 0.9032. The 0.9032 is going to give me this area, right? The area to the left. So if I want to find my area to the right, that area is going to be 1 minus 0.9032. So if my total area is 1, I'm going to subtract off the region that I don't want to count, and it's going to leave me what's left. So if you do that subtraction, that you get this area over here to the right is going to be 0.0968. So we just found that the probability that the edge gets more than 27 miles per gallon is 0.0968 or 9.68%. So there's going to be less than a 10% chance that the edge is going to get more than 27 miles per gallon. All right, very good. Let's take a look at another one. What's the probability that your forward edge gets between 19 miles per gallon and 23 miles per gallon? All right, so again, let's start with a sketch. All right, so for the original distribution as a mean of 24 and a standard deviation of 2.3, and I'm looking for it to be between 19 and 23 miles per gallon. So 19 and 23 are both to the left of 24. So 19 would maybe be somewhere out here to the far left, and then 23 would be even closer to 24, which is in my center. So I'm looking for it to be between these two values. So if I want it to be between 19 and 23, we're going to shade the area under the curve in between those two markers. In order to figure out that area, we need to move everything to z-scores. So for the 19, its z-score, maybe I'll call it z sub 1 because I'm going to find two z-scores, would be the data value, which is 19, minus my mean, which is 24, divided by my standard deviation, which is 2.3. That value, already rounded to two decimal places, would be negative 2.17. My other z-score that corresponds to the data value of 23, maybe I'll call that z sub 2, would be the data value, which is 23, minus the standard deviation, minus my mean, which is 24, divided by the standard deviation, which is 2.3. So 23 minus 24 divided by 2.3 is approximately, to two decimal places, negative 0.43. So let's rewrite everything in terms of the standard normal distribution. So I'm going to sketch myself a new curve. Under the standard normal distribution has a mean of 0 and a standard deviation of 1. And we are going to go put down the z-scores that we are working with. So I have negative 2.17, which is going to be kind of all the way out here to the left, and negative 0.43, which is going to be somewhere closer to my 0. And I'm trying to find the area in between them, so let's go ahead and just mark those. All right, so my game plan is, remember that my table will always find the area to the left. So the first thing I'm going to do is I'm going to find the area to the left of the negative 0.43. Now that calculation is going to give me the area that I want, but it's also going to give me the area out here in the tail that I don't want. So then our second thing we're going to do is we're going to find the area that's out here in the tail that we don't want. That's going to be the area to the left of the 2.17. If I subtract that off of the other area that I found, it's going to give me what's left, which is the region that I ultimately want to find. All right, so let's go ahead and start getting some of those numbers. Okay, so we are looking for, just to kind of quantify what is that z-score interval we're looking for. We're looking to figure out what is the probability that my z-scores are in between negative 2.17 and the negative 0.43. So negative 2.17 is going to be less than the z-scores that I want, which is going to be less than the negative 0.43. So that's the region that I'm looking for. First off, we're going to find the area to the left of the negative, which I'm going to write z is equal to negative 0.43. Right, to the table, negative 0.43. So let's come up to the negative values. Negative 0.4 is right 0.3 would be up here at the top. We find out where that row and that column intersect. I'm getting an area of 0.3336. So let's go ahead and record it. The area to the left of that is 0.3336. Now that area, again, is going to give me all of this, the region that I have shaded in red, but it's also going to give me that part out there that I don't want. So now the next thing we're going to do is we're going to find this area that is over here that I don't want. We're going to subtract it out. That area corresponds to the area to the left of z is equal to negative 2.17. Let's go ahead and find that area. So back to the table, negative 2.17. So here's negative 2.1, and now I want the 7 up here, so intersection of that row and that column gives me 0.0150. Alright, so is 0.0150. So the area between negative 2.17 and negative 0.43 is, we're just going to subtract those two numbers, 0.3336 minus 0.0150, and if we subtract them, we get 0.3186, or as a percent, 31.86%. So what we just found was there is a 31.86% chance that the car will get between 19 and 23 miles per gallon. Now, one thing I want to point out just at the end of looking at these examples is, depending on how you're getting your areas, whether or not you're using tables or technology, sometimes you might get slightly different results due to various rounding and or programming on the softwares and things like that. But the values that you get should be very, very close to these values, maybe just off in terms of tenths or hundredths of a percent.